The Agile worldview places a very strong emphasis on technical excellence and particularly on quality of the produced software. Much of this view of quality is based on testing, and most of the practices that we're going to see now are focused on testing. Most of them also originate, like those in the previous segments, with extreme programming, which is the most technically oriented, the most software specific of all the agile approaches. The first practice is not specifically related to testing. It's the idea of coding standards, so it simply tells us that for each project there should be a set of conventions, style guidelines, style rules, and such, which project members should adhere to. This is hardly revolutionary and hardly new with XP, but it was worth repeating. Now we come to testing, and first we come to one of the principal contributions of extreme programming to software engineering, the idea that we should never write code without associated unit tests. So the idea here is that whenever you write a piece of code, you should also have a piece of test that goes with it, a test or a group of tests that exercises it. Now the question arises immediately of the order in which we are going to write the code and the test. Let's defer that question to the following slides, but regardless of the answer to that question, one of the main contributions of the agile view of software development, specifically extreme programming, has been this idea, which has really been widely adopted by many teams, whether or not they apply other agile techniques. Do not ever write code without immediately having the set of tests that goes with it. It's a very sound practice, widely adopted today, deserving to be even more widely adopted, and one of the major contributions of the agile movement. A related practice, which is perhaps a bit more difficult to apply, is the practice of making sure that all tests pass before the team moves on. So this was a principle in our list of technical principles of agile development, and here it gets translated into a specific practice. Do not move on to, for example, the next user story to be taken on by the same developers, or for the whole team, and more ominously to the next release. Do not move on until all the current tests pass. Now this of course is hard, because sometimes you might have the temptation to say, well, okay, these are almost all the tests pass, can't we move on, we need new functionality? And the strict agile view here is to say no, until all the tests pass you're not permitted to move on, because it decreases the quality. And if a test is not so important, then remove it, and remove the corresponding functionality, but you should not continue until you have the expected level of quality. Going even further, we have the notion of test-first developments, which really comes from extreme programming, and it is one possible answer, one of the two possible answers to the question that I left open a moment ago. If with every piece of code there is a test or several tests, in what order do we write them? Well, test-first development says we should write the test before we write the code, and the test in this role becomes a replacement for the specification, in the same way that we replace requirements by user stories at the level of overall system description. Then at the level of coding, at the level of the code, in the same way we replace specifications, traditional specifications, by tests. So here's how Ron Jeffries, one of the main voices in extreme programming, describes this process. Here's a really good way, he says, to develop new functionality. Find out what you want to do, write a unit test for it, run the unit test. If it succeeds, you're done for that step. Go back to step one. If not, well, fix the problem and try again. And he says, try it, you like it. He cites a number of arguments for this approach, guaranteed flow, it goes faster, and so on. This is not, of course, a scientific demonstration, but enough people have tried it, and enough of these have liked it, that test-first development has gained some traction. It actually can be generalized into an entire development method, a unified development method known as test-driven development, coming from Ken Beck, who wrote a book specifically devoted to it. And here we have the entire development method. So what Ken Beck tells you, and it's quite a challenging view, of course it's very extreme and it doesn't necessarily apply to to every kind of software development, but it's certainly intellectually challenging. He tells you, here's the way you should develop software. Add a test. So the first time around, that's all you have, right? You have one test, no program, nothing, no code, no specifications, of course, no requirements, just a test. Run all tests. The first time around, of course, there's just one test, but as you apply this process, you're going to accumulate tests. Of course, this is a cycle, right? You are going to repeat these steps. So run all the tests that you have so far and see if the new one fails. Really, it's see the new one fail because you expect it to fail. After all, you have not written any code corresponding to that functionality, so how could it be except by magic or by miracle that the code succeeds? So in that case, you expect it to fail. So write some code is the next step to make sure that the test now passes. Run the automated tests and see them hopefully succeed. If not, of course, fix the problem, and so that it might be a bit of a loop here, and refactor code. So this last step, of course, is critical because if you didn't refactor, you would have very piecemeal code, right? If case number one, then do production of result number one. If case number two, produce result number two, and so on. This would not be very good code. So this is where refactoring, as studied in the previous segment, is critical to make sure that we keep the long-term perspective. Now, advocates of this approach cite many benefits for it: catching bugs early, getting more tests in the end, which of course is good, as we're going to see. The regression test suite is one of the prime assets of the project. Obviously, it is not appropriate for more complex programs which require some abstract thinking ahead of time at the beginning of the project, but it's certainly an interesting idea which has been quite influential. So the major benefit is the regression test. What's the regression test, or specifically the regression test suite? It's the accumulation of tests that failed earlier. It's one of the major assets of a software project. It turns out, and this is a phenomenon that is probably specific to software, that all bugs have a tendency to come back, and having a regression test suite makes sure that the Hydra doesn't pop a new head all the time, or at least if it does, you fix it right away. So the general idea is that whenever you have an important step if you're in your project, at least before any release, but probably before every integration, as we saw in the previous segment, you completely run the regression test suite and you correct any bug that has reappeared. There's also a variant of TDD which is a bit more specific and which I invite you to look up in the bibliography. It's contract-driven development, which somehow reconciles test-driven development with more standard ideas of specifications. A practice that goes with the previous ideas, maybe it's halfway between a practice and a principle, is the observation that a bug is not an error in logic, it's a test that you forgot to write. So in this slogan there's something interesting, which is somehow putting bugs in a proper place in software development. Bugs are not just something shameful that you try not to mention. They're a part of the software development process, and they are closely connected with tests. So in the extreme programming view, a bug is simply a test that you forgot to write, so it's not such a big deal. You write the test, you fix the code, of course, and then the bug rather becomes history, except that it is in this regression test suite. And I cannot enough emphasize the benefit of making sure that any bug that has ever been found in the development of a software system finds its place in the form of a test in the regression test suite, because as I emphasized, in software development, all bugs have a tendency to come back and haunt you because of shared psychological modes of thinking for programmers and other reasons. So you need to have this regression test suite, and it's to the credit of extreme programming and agile methods to have put this notion of the regression test suite at the center of our concerns. They also tell you, particularly in extreme programming and Scrum, that when you have a bug, you should not just fix it, but analyze the causes. So see that we have now changed the viewpoint, because earlier in test-driven development, we were talking about tests that we expected to see failing. Here we're talking about tests or executions that we did not expect to see failing, but which did fail. So these are bugs that are found after the fact, and they should become part of the regression test suite. And what the promoters of this idea are telling us here is that you should not just be content with fixing the bug, you should go deeper into the root causes to make sure that you are not just fixing the symptom, but fixing the cause, and in particular helping make sure that it doesn't happen again. There's also another rule which has to do not with unit tests as the previous discussion, but with acceptance tests. An acceptance test is a test that is meaningful to the customer and which is applied typically to the system as a whole, not just to a part, a unit of the system like a class, for example. And the advice here, the practice, is to have these acceptance tests organized carefully, automate their running so that you can run them often, and publish acceptance test score to the team so that everyone can know what's going on. What we have seen in this segment is that in extreme programming, at least, and in many applications of agile methods, it's the test that really drive the development. Code follows tests rather than the reverse. All tests should pass, and tests really replace specifications. This is, of course, a set of ideas that are somewhat extreme and controversial. What is not controversial is the central role of tests in software development, the need to have tests associated with every single piece of code, and the central role of the regression test suite.